Hi, good morning, good afternoon, wherever you are, and welcome to the latest in the Vordel series of webinars. Today we're joined by partner Amerindia, and our exciting topic for today is REST API security, leveraging Oracle Access Management and CA Siteminder. A few housekeeping rules before we start. On the screen you should see some dial-in numbers, but also a technical support line in case you're having audio problems. All attendees will be in mute throughout the webinar. However, if you do wish to submit questions, use the chat box in the navigation bar on the right-hand side of your screens to submit questions, which will be collated throughout the webinar. And at the end of the webinar, we'll have time for a Q&A session. So I'd like to introduce our speakers today. And we're joined by Wayne Delisser, Senior Solution Architect with Vordel, who will be our main presenter for the day. We're also joined and glad to welcome Raj Mittal, VP of Technology at Amerindia. Raj, if I could allow you to introduce your company first, and then we'll hand over to Wayne.
Sure. Thanks, Hugh. Hello, everybody. Amerindia is an agile system integrator providing sensible security solutions in IAM space, SOA, and API security, and cloud security. We are based out of Plainsboro, New Jersey, in USA, and we provide jumpstart solutions from gap analysis to assessment, design to development to deployment, full SDLC implementation, support and training in IAM space using Oracle Identity Management Stack, and API security using Vordel API Server. Back to Wayne.
Good morning. Thank you. My name is Wayne Delisser, and I'm one of the architects at Vordel. And today we're really going to dive into this area of what exactly is REST and how can I apply my legacy identity and access management solution for the things that are coming out, which are the REST and REST security. To do that, we're really going to talk about exactly why are people moving to REST, what are made up of the components of a REST security solution, what are the challenges that you run into if you try and use just the tools that you've had in the past, how can we actually secure these REST interfaces, these APIs with the Vordel API server, and then finally we're going to talk about some patterns and integration patterns with Oracle and CA. When we start to talk about APIs, APIs look very similar to what we used to call services, and they're just very similar interfaces to the older paradigm of machine-to-machine communication. The reason it's really called an API really is this push towards using more of the easier protocols like HTTP and using a lot of the methods that everybody's been doing for the browser-based things, but trying to apply it to mobile devices. And mobile devices has really pushed this area of how can I use my infrastructure in an easier, more efficient way. So for example, a mobile device doesn't really have a lot of memory, it doesn't have a lot of processing, so parsing an XML document is not exactly the best use of the mobile device. But there are other technologies out there that bridge XML to another format like JSON, and we'll get into all those things a little bit later. Now, everybody's talking about REST APIs, and you could see that over the time there's been an explosion of these APIs. And you could see from the subset of companies, there's quite a few companies out there. Everything that started in the 2005s, Google, Flickr, Yahoo, those are basically social media ones. And if you look at it, there's really not a lot of financial ramifications towards those APIs. But as you move up the chain to 2011 and 12, you'll see that there's a lot more companies doing things. And this is really the explosion of enterprise REST interfaces and REST APIs. It's really now there are financial things associated with it. And so there needs to be sort of a bridging technology between the non-commercial things and your enterprise security devices. And that's where when you look at the things that worked in the social media OAuth, it may not necessarily work for your enterprise. And that's where the enterprise standard for authentication and single sign-on is the Oracle Access Manager and Oracle Entitlement Manager, and as well as the CA Siteminder. How can I bridge those two gaps? And that's how we do it. Now, when we look at REST, I put a little snippet on the left, which is essentially an XML block. And our CTO is Mark O'Neill. He does have a web services security book out there, so this is sort of a little plug out for him also. That is the information is contained in a tag, the ID. This is the ISBN number, the author, the title, and it's enclosed in an XML open and enclosed block. Now, that works great when you have a lot of processing because you can process the whole document. When you go down to a mobile device, that block actually takes a lot of processing. So there are things like JSON. And if you look at the equivalent block on the right-hand side with the moon, the REST interface, instead of using just standard XML, we're using JSON. So the same exact block, essentially, if you look at it, it just has an opening tag and there's no closing tag with the corresponding. And it is easier to read things into things like JavaScript as opposed to just a Java application. So on the REST, if you look at it, it's more of the web technologies. Things are resource-oriented. And then on the left-hand side, this is where we run into a lot of middleware divisions within companies, where it is a service-oriented architecture, where we've been, in the past, focused on publish, binding services, binding, and it's actually been very complex. And so if you look at the explosion that we had, REST is very simple, and that's actually part of the reason why it's just exploded. And as we move on, some of the problems that you'll find with the REST interface itself really is it breaks down into the old same paradigm that we have for security. So it really starts with confidentiality, integrity, availability, authentication, authorization, auditing, and essentially data at rest and data in transit. Now, when we break that down, you could obviously see that the interface in transport and at rest, the interface itself, confidentiality, we have things like SSL, we have things to make the XML documents signed and non-repudiable, and obviously availability. Now with the advent of the cloud, things are in multiple places. Now, at access control, those are the things that the Oracle Access Manager and the CA Siteminder and the RSA Clear Trusts of the world do very well. They authenticate. They take a user ID and a password, and it goes back and it validates it. The newer paradigms like the Oracle Entitlement Server, the Oracle, the Axiomatic products, those things do authorization. That's where we can actually authorize the service. We could authorize content within the XML block itself, and then auditing. And then data at rest is how we consider data security and as well as data in transit. Now, some of the challenges with just using a typical web access management product is that on the interface side, if you have a mobile device like an iPad or an iPhone or an Android device, there's very little to really recognize the actual device to pass that on to the web access management product itself. A lot of customers will say, I really need to start to collect information about the device. I understand that the user could be authenticated on the back end, but I need to now have a mechanism that I could collect the serial number, the ID of the device, and actually pass those parameters in to make sure that this is a trusted device. Then the access control product itself, with just an IAM product, is really, it doesn't really handle the device itself. So when you authenticate with a username and password, traditionally without any add-ons, it's very difficult to fingerprint the device and actually then make sure that the application has the right version to get back into your system. The other part is many times they're bolt-on products like Federation. So if you had a device and the device needs a SAML token, you would have to get a bolt-on product to that. But there's also this whole new area of token types. So if you have a proprietary token, which is very good for certain things, on the enterprise you want to make sure that you have single sign-on. You authenticate with a username and password, and then you pass that secured token from one subsystem to another system. But when you have a mobile device, the token might be a little bit big. It might be a separate token. You may not have a web service. You may have a disconnected system for a period of time. And then finally, with data security itself, there's really not a lot of standards on there. But we do see a lot of customers looking to prevent data leakage, that they'll use some sort of fine-grained authorization solution, which is, again, when you look at a strict access management solution, it really is just a URI, and URI is really what we consider coarse-grained. So now, as we move on, we've introduced a new server. It's called the API server. It actually manages and delivers APIs in a secured manner. So if you look at just a server in general, the API server is made up of several different components. It's made up of an API transformation. It's made up of API control and governance, API security, API monitoring, API development lifecycle, and API administration. We're not going to go into all those things, but the API transformation is essentially a REST to JSON transformation. The API control and governance is actually the visibility of the API. The security is token types. Do you want to encrypt things? Do you want to sign things? Do you want to use a transmission level? Transferring tokens from one format to another, so the Oracle Access Manager to a SAML token, or an OAuth token to an Oracle Access Manager token, or a Siteminder token. And then the whole life cycle of the API. So every single mobile application has a life cycle. So you have versions, version 1, version 2, version 3, especially for the platforms. We have an infrastructure that accounts for that. And then finally, the API administration. The API server acts as the front door, the entry point for all my cloud services, my partners, my mobile devices, all my web applications. And once it goes through the front door, we put it under our control. And again, that's through transformation. So this is an example of how our policy works. And it's very, very simple. Once you go through the front door, we actually now start our policy model. And you can see the way that our policy model works is that at the very, very top, you get authenticated. And that's what we have to start. So once you're authenticated, you get authenticated with the Oracle Access Manager or some other subsystem like the CA Siteminder. And then now you move down our policy model. And the reason it's so simple is that you just basically have a binary yes or no, a positive path or a negative path. And so you could see that if you pass the authentication model, I already know who you are. Now, the second thing that we could do is add in additional things. So you'll see that we have a throttling. So what this does is that it prevents people hogging the service. So this is, again, when you hit a REST interface, you could prevent the throttling of it. You could only use the service, call the service 5 times a second or once a second, and it's really up to you to decide what that is. Now, as you move down, you can see where there's a negative or a red line. That negative is basically send a tweet. Basically, this user is hogging my web. Now, at the positive side, you could see that the next step, if you pass the throttling, you're not over my limit, then you go into what we call validating the REST filter. After you validate the REST filter, we go on to validate the query string. Once we know that the query string and the filter is well formed and it adheres to my corporate standards and the tolerance of my API, then we have something that says basically get all the attributes from the query string, and then this is where we have an example of how we could take those query string attributes and create a SOAP message for legacy systems, and then we connect to that SOAP backend. Then we essentially, the next steps, we transform that SOAP message, that XML message. We ask for authorization from the Oracle Entitlement Server. And then finally, we convert the XML output to a JSON message. And this is an example of how a trusted policy model, we've authenticated the user, we've validated the query strings of the REST interface, we've then gone down, taken the parameters, created a SOAP message for a legacy system. On the return, we've authorized certain content, and then we've converted it into a JSON object which you could consume on a mobile device. Now, when we start to dive into a little bit of what exactly is REST, and we won't go into the philosophy of REST or not, but this is where we do sit into a lot of meetings that they'll have the traditional middleware developers, they'll have the traditional identity and access management sort of developers, and then they'll have their mobile and cloud initiative guys. And there's a lot of finger pointing because everybody's trying to figure out like who really is responsible for REST. And this is where, if you go back to traditional middleware essentially is SOAP and XML, and it has its place. And if you look at identity and access management, it really is focused on the URI and the URL and authentication and authorization of that URL. Now, when you look at the cloud and the mobile initiatives, everything sort of, that's the dissection and the intersection point of these worlds. They kind of meet. And when you have a strictly social API, the enterprise doesn't really have to get involved. But when you have an enterprise API and you're exposing actual critical data through this, you're going to have to get the middleware involved. And that's where the middleware will have their SOAP, and that's why we spent a little bit of time of bridging the two. Without modifying the SOAP service, we could actually work with it. And then the identity guys, this is where you could concentrate on the authentication and the coarse-grained URI. And then this is where the REST. So REST is just a URI. And this is an example of you have your sort of your relative path off of our front door. In this case, it's just api.vordel.vm. We have a resource, which in my example is customer record. And then we have basically a question mark with a query and a fragment. Now, this is where we have the security and the REST. So traditional identity and access management vendors will do the URI very, very well. They'll do the gets, the posts very, very well. But it's this query string parameter that kind of breaks down. So if you look at the following three examples, the customer record is the actual resource that we're enacting it. We have the same exact query string. So it has the question mark, F name, Jane, L name, Doe. So that's Jane Doe. Now, what we want to do on the back end is essentially we want to return from our repository the information for Jane Doe. So you could call the resource with the get statement and you'll be able to return it down. Now, equally, you take the same query string and you could actually do a put. And the actual HTTP method is going to drive the functionality. So this is where you can now, if Jane Doe is in existence in your backend repository, you'll be able to modify Jane Doe if you were to add additional query strings. And then you could basically do a post to add Jane Doe to the database. That's how things really work in the REST scheme. So when you have this paradigm, everything is essentially the same query string. Everything is off of the same URI to get authenticated, but the actual functionality of what you can do actually is modified by very, very light things. So to give you a little bit more control, what we've done is we've created these filters. And these first filter is really this REST filter. And this is just a simple example of a whitelist of the HTTP method. So in this, you could see where now I'm only allowing the HTTP method get. So if I try to do something like post, you really can't do it because I've disallowed it. And this is how it secures your backend infrastructure because, again, when they come through the front door and they're trying to do something that they're not supposed to do, you'll get an alert. This is where you could print a report of the underlying clients making a request in, and if the client is trying to do something other than my whitelist patterns, you'll have full visibility into that, and that's all facilitated through the API server. Now, to further restrict that query parameter, I basically registered the three parameters that my query string will only take. So that's my first name, last name, and middle initial. If the query parameter is anything other than that, I've just basically said reject it. So this is where it eliminates people trying to put in things in the value to see what returns back. Now, the second filter, after you meet the HTTP method, I've created this validate query string, and you can see where it has a regular expression. And the regular expression match that I put on for the middle initial is just an alpha character. If you know it's a numeric, you can, or if you wanted to write your own regular expression of what the permitted query expression would be, you would put that in for all the values. And again, if you check this as, if anything shows up other than this, you could reject the transaction. And again, this is above and beyond just the URI. This is the question mark and the stuff after it. Now we've also in here, I've put in known attacks. So when you're doing a query to a database, if you add into the query string things like SQL deletes, SQL drops, SQL insert attacks, things like that, we just, by just selecting it, we just check those things. All those things will be rejected from the system. Now, this is an example of how we've had customers come back and say we want a higher degree of authorization beyond the URI. We actually want to take the context of the transaction. You are coming in through Facebook, I really don't care. You get authorized to data, certain subsets of data. But if you have an API exposed to Walmart, Walmart may have a more financial ramifications to it that you have to actually adhere to a service level agreement. You might want to add in that context into the authorization of the content that's returned back down to the JSON object. We also have worked with Salesforce with their data residency option, DRO, which has the ability to flow information down to the endpoint to encrypt, decrypt, and tokenize the requests all the way down from Salesforce down into your organization.
Okay, thanks very much, Wayne. Now we're going to go to some audience participation. Guys, this is your chance to provide us some feedback at this point in time before we transition to the next presenter. So we've posed a question there, which hopefully you can all see on your screens. And if you can click the radio button, which best reflects your answer based on your knowledge of what your organization is using REST APIs for. We'll collate the information and then publish the results momentarily. Okay, you're all busy clicking away there, I can see. The numbers are changing gradually. I'll give it a few more moments. Okay, a little bit more time. Approximately 60% have voted. Okay, oh, you're still voting. Come on, that's it. Well done. There are two clear winners, but okay, we'll close it there and we'll publish the results. So hopefully you can see on your screens there that enabling mobile applications by a head is out in front at 48%, almost half of you, which is quite impressive, followed closely by integration with cloud-based services. Quite interesting information there. We'll now transition to our next presenter, who is Raj Mittal from Amerindia. So Wayne, if I could ask you to move the slide to the next slide, and Raj, we'll have you take over.
Sure. Thanks, you. Now, whenever different clients, such as mobile devices or web applications, make requests for an API access, two major steps have to be performed. The first, the user and a client authentication, and the second is the device authentication. Now, in the context of the user authentication, Oracle Access Manager and Siteminder are built in as a user authentication and an SSO product, which helps in performing the user authentication. Now, let them do what they do the best, and we can extend to using technologies like Vordel API Server. Vordel API Server acts as a super policy enforcement point. It gathers necessary information about the user, the application, the device, and network context data to enable the authentication decisions. Vordel API Server can replace Oracle Access Manager, WebGate, and the Siteminder agents that needs to be configured to perform the user authentication. It can act as a single API server, as a policy enforcement point, and also for policy enforcement point for Oracle Access Manager, Oracle Adaptive Access Manager, and Oracle Entitlement Server. The second point, the device authentication, is coordinated by Vordel, and which is delegated to a device authentication API that can be fronted in front of the databases and in front of various application registries which can perform the device authentication. Next slide, please. Next slide. Okay, thank you. Clients, employees, partners, and customers need regular access to heterogeneous platforms, identity systems, various protocol, etc. How can this integration happen seamlessly? This challenge becomes more complex when we have new cloud-based applications such as Google, Facebook's, and which also brings in additional OAuth and OpenID Connect authentication schemes that must be incorporated now. So what would be the best approach and the solution for it? So the best approach and the solution is to add security token service to the existing IAM footprint. STS provides a centralized mechanism to broker trust between application and web services by seamless identity propagation and security context. Vordel does exactly the same. Vordel offers a full-featured and a flexible STS built into the API server, and it can mediate all popular standards, and I also manage the interaction between Oracle Access Manager or Siteminder and even Kerberos. We don't need a separate federation product if the API server is already in the architecture. Next slide, please. Here is an example of how STS policy can be used, which ingest an OEM OBSSO cookie coming in and generate a SAML profile based on that particular SSO token, which can be forwarded to the federation site to perform the authentication of the authorization. And there's another screenshot about the OAuth authorization servers, how the OAuth configuration has been done within the Vordel API server. So overall, Vordel provides a flexible STS engine that can facilitate between multiple protocols, multiple systems, and authentication system, and provide a seamless access and propagate those identities, information to the various systems. Next slide, please. Now, we saw the example of how the authentication has been performed, but then what about authorization? And then you saw a policy model described by Wayne a few slides back, in which the fine-grained authorization have to be performed. Now, why we can't use Oracle Access Manager or a Siteminder kind of product to perform these kind of authorizations? We can do that, but they are limited to performing coarse-grained authorization, whereas Oracle Entitlement Server provides a fine-grained authorization, a policy-based fine-grained authorization, which is designed to externalize authorization from applications. But it still limits itself to perform only the decision points. The enforcement points are lacking. So in that scenarios, we can have Vordel API server be one of the policy enforcement points for Oracle Entitlement Server. All those policy decision points from Oracle Entitlement Server will be deployed in the API server, which will also further guarantee a better response time for the authorization request. The Vordel API server makes it possible to enforce OES policies even for the legacy backend system. And that's an example we will see in the next slide. Now, here is a role-based example in which Vordel API server is collaborating with Oracle Entitlement Server. Now, on the top right-hand side, we see a legacy patient record application which is not aware of the role-specific or the attribute-specific information. It always returns the same data set, which can lead to compliance or the security exposures. Now, if Oracle Attachment Server is there and Vordel API Server is fronted and acting as a policy enforcement point, Vordel can gather user information, device information, and application-related attributes and perform and delegate certain functions to OES, and then gather those responses back and can distribute it to the various different users and the business applications. So Vordel API Server allows us to configure a standard information into a role-based information which can be ingested or which can be consumed by different type of users or different type of applications, such as appointment help desk, accounting, or the doctor, as shown in this example. Now, does API Server has to perform a lot of processing, and then what exactly we need to do? So just to touch upon that, the data from the legacy API can be redacted on the fly. There is a minimal configuration that needs to be performed at the Vordel API Server to get this working. Now with that, I asked Wayne to cover up the recommendation for the REST APIs.
Thank you. So we're about to wrap up, and we have our sort of recommendations moving forward for REST, and REST, I guess you could say, equals mobile and cloud. Now, the very first thing that we always recommend really is establish an enterprise-wide API development best practice. I know that sounds very lofty, but it is actually, that's how you get started. What are the things that we're trying to do? What are the authentication mechanisms that we're trying to do? Who are we connecting? And really, what are the back-end services that we need to do? So if you go back to my example, is this just a mobile API that's connecting to a social device and it really isn't an enterprise API? Well, you don't really need to get your SOA departments involved. But once you start to interact, once you get Salesforce making a call, not single sign-on to Salesforce, but actually to generate quotes or get information, Salesforce would make a communication path back into your organization. This is where you're going to have to say, okay, I need to look at the token types that Salesforce is coming in. I need to validate the authorization of the information going back to Salesforce. Those are the things that you're going to have to start to establish. Now, the second thing really is just to remove API security from the development. Now, the good thing about OAuth is that it's very open and loose. The bad thing about it is that it's very open and loose because that's undergone many different revs. So we're on Rev 28. So you really kind of want to not build any kind of tight coupling to this rev that keeps changing. So if you're committed to that, we do believe that you put it in the abstraction layer. So just like you would do for your SOA middleware, you would do the token mediation in another layer. The third recommendation really is to architect a comprehensive API security, just not in parts. And if you look at our recommendations of trying to do it just with one product was built at a time in space when the browser was king. Now, essentially, there's a heck of a lot more mobile devices out there. There's a heck of a lot more development in the cloud, not on-premise, but you still need to bridge those things. And we do believe in our strategy. The API server is the front door. Once you go through the front door, we control the entity. We could collect information. We could call and coordinate, orchestrate, both with REST, HTTP, XML, and SOAP. The fourth point that we have is really to consolidate your access control across the user, the API, and your business-to-business traffic. So again, when you really look at your environment, things are becoming porous. You have things in the cloud. You really have to have that front door. And if you think the front door is a firewall, the firewall will give you a port, but it doesn't really give you the necessary things to open up new channels, converting the HTML and XML into basically JSON or whatever standard you want it to go downstream. Extend your Oracle, Siteminder, and Tivoli investment. It's really good at authentication. It's good at coarse grain. But again, what is really lacking is that powerful enforcement point. Again, that's the API server. It comes in through the front door. We could do the authentication off of whatever mechanism. We could propagate the identity and then ultimately route you to your backend service or route you to your cloud service. But it all starts with you have to go through the front door. You can't be porous. If you have a REST interface off of a web server and you think you could do it with a load balancer or a reverse proxy, you'll find that it's actually very difficult to do the transformations and the actual channel routing that way. And then finally, we really do think that if you rationalize what you have, just look at reducing the amount of touch points that you have, especially for comparing the new development and what you have on the back end.
That's great, Wayne. Thank you very much. Before we go to the Q&A session, I'd just like to advise you that this recording will be made, a recording of this webinar will be made available on demand from the Vordel website within the next 24 hours, and we'll send you all a link to that. We'd like to push one more polling question to you so that we can better serve you in the upcoming series of webinars. We'd like to look at which topics you'd like to see covered in future webinars. So again, I'd invite you all to select a webinar that you would really like to see presented, and we will do our utmost to cover that in the series as we go forward the rest of the year. So if you could please pop in your questions there, and we'll present the results so you can have a testimony and a witness to the fact that we have to present this in the series. Okay, that's great. Thanks for your votes, folks. Okay, we'll publish those results now, and there you go. At the top of the list, we have OAuth, followed closely by, well, a close second is second and third there, cloud and mobile. So, funnily enough, or coincidentally enough, coming up in our series, we do actually have a presentation on OAuth patterns for the enterprise. That's scheduled for October the 25th. If we go to the next slide, you'll see what we have coming up next, which is on October 4th, a joint presentation from partner Proficient and Vordel CTO Mark O'Neill on securely exchanging healthcare information across multiple stakeholders and platforms. And this webinar, whilst on the face of it looks at the healthcare sector, will have relevance to all of you in your various industries, because we'll be examining the challenges and opportunities presented to the enterprise as they look to leverage cloud and mobile. And then on October 25th, we will in fact have a webinar on OAuth too, so please make sure to tune in for that. So we're just going to go now to some questions before we terminate or finish the webinar. And I have a few in. I think the first question I'll put to Wayne, and it's around OAuth in fact. It relates to the following. Is OAuth 2 the best security standard to use with REST APIs? And are there any other standards we should also consider? So Wayne, have you any thoughts on that?
Well, wow, you guys really get right to the heart of it, doesn't it? I do believe that you look at the token types that you have first. And if you have an Oracle Access Manager or a Siteminder, those are your sort of enterprise token types. I do believe that that's what you look at first. Now, when you look at mobile devices and cloud and token types that you're accepting and token types that you are producing for those providers, those enterprise tokens may not necessarily be the best use of it. So I would say that OAuth 2.0 is the best token type if you wanted to look at external. And then bridging it, I would look at using the API server to bridge it to an enterprise token on the back end. And there is a sort of a hybrid of tokens, which is sort of a JSON web token, which is getting a lot of traction using a SAML assertion within an actual JSON object, and we will be getting into that at the later WebEx or web conference.
Okay, thanks, Wayne. Raj, a question for you. I have mobile applications that call multiple APIs. So in the architecture that you discussed, how is single sign-on done across the APIs? And does the Oracle Access Manager or Siteminder have an active role, or is the SSO token just cached at the API server?
That's a very good question. Vordel API server authenticates mobile application once, either against the Oracle Access Manager and Siteminder. And Vordel API server has a caching mechanism which is distributed against multiple nodes if deployed in that type of an architectural topology. What Vordel API server can do is it can cache that token session, either generated by OAM and Siteminder, for further usage, so that the applications or the mobile devices that needs to authenticate again, they don't need to submit the credential. They can just submit the token, and that token can be validated by Vordel, so that it does not have to be passed to either Oracle Access Manager or Siteminder, and thereby reducing the latency as well.
Thanks, Raj. Wayne, one for you, I guess. Can the API server generate and manage API keys and certificates, or do I need separate tools for that?
No, absolutely. The API server could actually generate, can act as an OAuth resource server. It could produce OAuth tokens. It could actually manage third-party API keys, or it could generate API keys. We have a set of REST interfaces for user management, and we could absolutely, part of that user management is to issue certificates and manage the API keys in a central repository.
Great. And another one for you, Wayne. You mainly talked about securing my own APIs, but we use a lot of third-party APIs, both open and enterprise APIs. Can the API server help me manage the security requirements from partner APIs?
Absolutely. So you could actually specify different policy levels. So policy when a partner connects to your environment, so the Salesforce is coming into your backend infrastructure, we could set the policy. And we have, for certain partners, our software, we could actually take the API server and strip it down to a smaller component, which you can actually run in the cloud or on the partner site.
Okay, great. So Raj, one for you. I think it was in the Oracle entitlement server use case that you provided, OES. How does the API server compare to the OES security modules?
Now, we know OES externalizes the authorization piece from applications and then define those at the central locations. And those Oracle entitlement server security modules can be deployed and can ease up the task of providing the access to the Oracle entitlement server use case. But the API server goes beyond that. Those Oracle entitlement server security modules can be configured inside the API server, thereby having a central approach to the policy enforcement point. Whereas those specific Oracle entitlement security modules, for example, for SharePoint, that has to be deployed at that particular location, and it is only limited to SharePoint. But when you have an API server, it takes the security to the next level and acts as a central policy enforcement point, even for those policy decisions what OES has to make.
Great. And Raj, it's actually a final one for you as well. We currently use OWSM and OSP, the Oracle Service Bus, to protect our web services in the DMZ. But would you use the API server? Would it be better than that current solution?
Definitely. Let me touch on OWSM and OSB. When these two products are together, they are a great solution for a web service security. But Vordel API server takes the web services security to the next level by offering specific functionalities and a more advanced approach to web services policies, which are not being offered as a gateway or as an agent mechanism that is offered by OWSM sitting on top of OSP. Having Vordel API server sometimes is a strategic decisions for the organizations, for the enterprise architects to add new capabilities such as throttling, caching, threat protection, and most importantly, centrally managing those APIs which are beyond the scope of OWSM and OSB for any given solution. As a result, definitely Vordel API server is a solid product that can be put in as a first mile security or can be put in the DMC.
Okay, very good, Raj. Thank you very much for that. Folks, I'm afraid we're out of time. However, I know there are one or two questions that have been texted in, so what we'll do is we'll get back to you directly on those. In the meantime, I'd like to thank our two presenters today, Wayne from Vordel and Raj from Amerindia, for their time. And as I said, a recording of this webinar will be made available on the Vordel website. So we'll send you a link to that in due course. And be sure to register for the upcoming events. And we look forward to seeing you online very soon again. Thank you and goodbye.